No.
No, easy peasy. So, sorry, sorry. So part one, uh, e to the power of ln anything is equal to that same thing.
hmm Oh, it's just two. Like A is just two.
Yep. So that will be e.
E to the x ln two.
Yeah, and you could say it as e to the ln 2 to the x, and then
Yeah.
just move the x to the front. Yep. And then part two.
Um, why would you use? Oh, well, never mind. Um,
So the derivative of 2 to the x will be, is that how you write it? Yeah, will be the same as the derivative of e to the x ln 2.
mhm.
Okay, so e derivative of e to the x ln 2.
Um, I'm not really sure because
You
if you differentiate e to the x, you just get e to the x. But so would you just get e to the x ln two?
what if you wrote it as ln 2 x? Ln 2 is just a number,
Mhm.
and so the
Oh, it's like it would be ln two e to the power of ln two x.
yeah, e to the ln 2 x. What is e to the ln 2 x? Or e to the x ln 2?
2 to the x.
Yeah, and so ln 2 2 to the x,
Mhm.
or you could write it the other way around, 2 to the x ln 2.
Mhm.
And then question 3, part 3.
Wouldn't it just be e to the x ln x?
Y is equal to x to the x as an exponential. Hey, you're onto something there. Okay. So what would it be, sorry?
Would it be e to the x ln x?
So e to the x ln
No,
x.
I think the ln x would be like part of the power, like the first part.
Like that.
Yeah, I think so.
Okay.
So the derivative is just um would it just be wouldn't it just be ln to the x times e to the power of x ln x?
Say that again, sorry.
Would it just be like if you differentiate it, would you get ln x times e to the power of x ln x? Yeah, okay.
X.
I don't know if that's right, but
Oh, let's see. So it'd be um what did we do for this other one? So we said it was e to the ln. Yes, that's correct. Then we did the derivative, and so we do the whole thing, which is e to the ln 2x. times by the... Okay, so it's going to be dy by dx. I'll call it y dash. It'll be the whole thing, e to the x ln x, and then times by the derivative of x ln x, which I think you have to use the chain rule for.
Oh, okay. Mm.
And so derivative of first times second.
That would just be ln x.
And then plus first times derivative of second.
That'd just be 1.
Yep. Stationary points. So I think that's it.
Oh, you'd have to do dy by dx equals 0.
Yeah, so that will be equal to 0.
And then solve it somehow.
Yeah. It's one thing times another. So e to the x ln x. Or
ln x plus 1 is equal to 0. Yeah. But then you'd have ln x equals minus 1, which you can't have.
So no solutions for that one.
Yeah.
How much the other one?
Ln 0 is 0, right?
Don't think there is an answer, is there?
No, because e to the x ln x, you can't solve that either.
So ln 0, yeah. E to the x ln x. E to the x ln x, yeah. Let's take a look. That's what we wrote, isn't it? 1 plus ln x.
Oh, it's the same as x to the x. Oh, you can have ln x equals minus 1. I didn't know you could.
And
yeah. Why is it equal to 1 and not equal to 0?
What is the solution for ln x plus 1 equals 0?
Ln x is equal to minus 1.
Okay.
And then x is equal to e to the minus 1, which is 1 over e.
Yeah.
But you know, when they solve for the stationary point, they did 1 plus ln x is equal to 1, and I didn't understand it.
1 over e.
At stationary point, 1 plus ln x is equal to 1. Why?
Misprint.
Okay.
They meant it's equal to 0. And then, yeah, because you can see by their own thing, they subtract minus 1 from both sides. So they subtract 1 from both sides.
But then how did they get minus 1 when they've got ln x is equal to 0?
It's a misprint. They should have done that the way you did.
Oh, it should be 0, okay.
Yeah, because everything...
But then if you get ln x is equal to 0, you can't solve it. So... Oh, no, it's minus 1. Never mind. I understand.
Yeah, it's a misprint.
Yeah.
Everything they did before and after is, consistent with that.
Okay.
And what was this? Yes, we need a y coordinate, I believe.
Oh, you just put it back into x to the x. So, wait, you got x is equal to 1 over e. Mm-hmm. So 1 over e to the power of 1 over e. Can you solve that, or do you just leave it? That's the exact coordinate, so.
I don't know. We could do e to the minus 1 to the...
e to the minus 1.
E to the minus 1. And so power to a power, what do you do there?
Multiply.
So e
to the minus e to the minus 1.
So you could say,
I don't think.
do we even need to kind of, let's just see what happens. So e, so that's going to be to the minus 1 over e.
Yeah.
Is that any better? It's a bit better.
You don't need to solve it.
1 over e to the 1 over e. Okay, yeah, just left out of that. And so that's the point. We said, yeah. So 1 over e, and I prefer our way. E to the minus 1 over e. That's it. Okay, any questions there?
No.
Okay, hang on. Get rid of that, whatever it is. Okay. What is next? Okay, question 2.
Would that just be x is equal to e to the y? How do you prove that dy by dx is equal?
What would be dx by dy?
E to the y.
What would be dy by dx?
Oh, the reciprocal, so that's just 1 over e to the y, which is equal to 1 over x. Oh, okay. Okay.
Part 2. Wow.
Chain. So would that just be ln times 1 over x or something? Oop, that sounds wrong.
So it would be the derivative of the whole thing. So is it 1 over ln x? The derivative of everything. 1 over ln x, I think, times by the derivative of the function inside the function.
Times 1 over x.
I think so.
So that would just give you 1 over x ln x.
X ln x. Let me just make sure.
That's all right. Oh yeah, it is okay. I
Okay.
kind of forgot how to do chain rule.
Yeah, derivative of everything times derivative of function inside function.
Okay, that equals ln xx. You know the bit in the bracket, can you just write that as x ln x?
How does that work?
You know how when you have like logs, you can bring
This.
the power down. Yeah, that
Yeah,
one.
yeah.
Okay, so that would be 1 over x ln x
Yeah.
multiplied.
1 over. Okay.
That would be product rule, right? The bit inside.
Yep.
So that would be ln x
Yeah.
plus 1. That's it.
So
Ln x plus 1 over x ln x.
ln x plus 1 over x ln x and ln e
Okay,
x. Do you know what? Do you know? There's no really easy way to say it. You just need to notice it. Ln e is 1.
Oh yeah, that's true. But confusing. Oh yeah, and then
And
you can factorize out ln.
no,
No,
no, honey, no, no, no. You don't factorize it then. When do
looks
you
like
when do you
that.
see when do you see two
Oh,
powers?
right. When it's logs, you can multiply them.
Yeah,
Okay, forgot how
excellent.
maths works.
That's like people saying like divide by sign or something. It's like
No.
no, 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 no. Okay, that's it really. Got it. And they did something similar. Yeah, 1 became ln e. Yeah, what's the big picture there? Just put the power to the front, and
Mm-hmm.
then product roll. Okay.
Hard differentiation.
I'll never say that. Don't scare me.
Okay, ln 1 plus x. I think that's just 1 over 1 plus x, but I might be wrong.
Yeah, I think so.
Minus 1 plus 2x.
2 times a half.
Oh, 1 plus x.
Yep.
Okay, that's it.
Didn't seem very hard.
I don't really get the second part.
We could graph this and just find the minimum, basically. Show that f dash of x is always greater than 0. I just wonder, is there some... Are we supposed to... No, well, I suppose you can't show a graph to an examiner. You could
just make it equal to 0 to find the minimum.
Show that f dash of x is greater than 0. You could find the derivative of that, I suppose. I don't like the look of it though.
Second derivative.
Yeah. Oh, is it easy to find the derivative of that fraction? 1 over 1 plus x. Yeah, it's not the worst. Using some tricky rule, I bet. If what is the derivative of 1 plus x? It's just 1. So it should be easy to get the derivative of it.
Oh, is there a thing where it's like if the top of the fraction is the derivative and then I have no idea.
There is, I just don't remember out of my head. Other than that, we we could find quotient rule, and it'll be very easy because there's no x on top.
Fx differentiates to that, but I don't know how to differentiate if you have that.
All right, we'll use quotient rule, and it'll be.
Oh, okay.
So quotient rule.
But then the derivative of 1 is just 0. So how would you do quotient rule?
For one of them, it'll be 0. For the other one, it won't be.
Okay, so the one that would not be 0 would just be 1, I think.
Yeah.
So you just have 1 over 1 plus x squared.
I think that's it.
Okay.
Yeah. And then derivative of that would be plus 1, is it?
Yeah.
And we could say that's equal to 0.
So 1 over 1 plus x squared is equal to minus 1.
Mm-hmm.
And then I suppose you can multiply 1 by 1 plus x squared. I don't know how to solve this. Minus x squared plus 2x. Plus 1.
Yeah. So that's going to be minus 2 equals 0. And there's probably no solutions. Is that right?
I can check. Minus 1 plus I, so there's no solutions.
No real roots. Therefore,
squared minus 4 AC is less than 0. But that would be less than 0, not greater than. So how does that show that dy by dx is greater than 0?
Be greater than. Y equals 0. Y equals 0 is there.
Yeah.
So this has to be greater than 0.
Okay.
So
it's positive. Okay.
The f dash of x is greater than 0. I think for any real number for x. And so, yeah, including when x is greater than 0.
Okay, what about the second part?
Deduce.
I don't know. They just subtracted, which I don't really understand.
Ln 1 plus x.
They just did the whole like f of x is greater than 0, and then took away x and minus half squared. So I don't really see how that works.
So ln if they're to bring that to the other side, x is greater than or equal to 0, x greater than 0, that this one has to be greater than this. I don't know. I suppose if you take away x,
yeah, that's
then and this is all like greater than y, you know, y equals f of x, then yeah, this part definitely.
f of x is greater than 0, and then they just added and then they just wrote the x and the half x squared to the other side.
Let's see. What part was this? Part 2.
Oh no, okay. I don't know where they got that from.
So they did the derivative, and then they did it.
They solved the derivative.
They rewrote it as a single fraction. Since the gradient is positive for x is greater than 0, f of x is an increasing function. Since f of 0 is 0, the f of x is greater than 0. Okay. Therefore, for x is greater than 0. Okay. It's this thing up here. Ln 1 plus x minus x plus a half x squared. That must be greater than 0.
Yeah.
And so you just move those to the other side.
Yeah.
X minus a half x squared.
Mm-hmm.
There you go. Okay, question 3.
What? Where did they randomly get a third x cubed?
Well, the derivative of it is x. No, it's x squared. Let's see. Show that this... There's nowhere that has x cubed. I don't know. Ln... What? So you just conjure it?
Yep.
But that's so... Why?
That's
Yeah, you just know that you're supposed to just conjure from nowhere. Okay. Why do you take these integral things? Okay, so
gonna be like weird.
ln 1 plus x minus x.
So you just make your own function and then okay.
This would have to be then, I believe, minus.
Yeah.
And are we allowed to say that this is greater than 0?
And then you just bring everything to the other side.
But I think we have to go through the whole thing again, do we?
No, I'm pretty sure you just bring everything to the other side.
So you can just assume that's greater than 0?
Wouldn't it be less than 0?
Why would it be less than 0?
Because you know the ln 1 plus x in brackets, it says less than everything else. Like when you bring everything to the other side, it says less than. So I don't really know why.
Yeah, it seems like you're just using the...
You're just making your own inequality. It's just so weird.
You're using the question to get the answer, using what they've given you. So sure, I don't think that's really shown a whole lot though. I think we were supposed to do the whole thing again. So find the derivative.
What?
Show that there's no solutions. All that. Let's take a look.
I don't understand it.
So
yeah.
So they went through the whole thing again. So in theory, we should go through the whole thing again. Anyway. Okay.
Part 4 either. What is ln 3? But isn't that just ln 3 minus ln 2?
So I think you have to sub in a value for x to get those two things. Basically, the first one is greater than 0, the second one is less than 0.
Okay.
So ln x minus x plus a half x squared. So we said that was greater than 0.
Yeah.
What do we have here? Ln x or something? Something in the middle. And then this would be the minus a third x cubed one.
Mm-hmm.
No. If that's less than 0, then...
That one should be, before. And then...
So that's our lower bound. Something goes in the middle.
I suppose you could solve for x, but it's not really helpful. I don't know how you show.
Let's put ln x there, I'm sure.
But then wouldn't that mean x is equal to 3 over 2?
So maybe we need to show that using, let's say, the second one. So ln 1 plus x minus x plus a half x squared will be equal to 5 over 12.
Yeah.
Okay.
I don't know. It's a quadratic, I think.
Yeah. It's a quadratic arc. Hopefully I did it right. Minus x. Squared. So I'll get one solution this way. Well, there you go.
1.35.
Whatever that is.
Is that equal to something? Like a fraction?
Might be a half e or something. Hang on. So where's e? Shift. E to the 1. Is that the same thing? No, it's just close.
It's close, but no.
Let's see. I don't know. Putting x equals a half in. You sub in. Hang on.
Oh, it's because ln 1 plus half, it has to be 3/2. Okay, got it. Because the middle one is ln 3/2. So I think the ln 1 plus x bit has to equal.
Okay.
The inequalities are like that.
Yes, they made ln 1 plus x for both of them. Yes.
Yeah.
Yes, so you let
So
x be
x is
equal
half.
to a half.
And then you substitute and you find the other bits.
Let x be equal to a half. Okay. All right. Go on, sub those in. What do you get?
So get half minus half. 5/12 for ln 2 is less than 5/12. And the other one, (3/8) is the other one.
Yeah, so you would just sub in a half for it. Yes. And so basically, yeah, ln 1 plus x is greater than this one, but less than this one. So this one goes on the right, this one goes on the left. So that's what we had. And in the middle is not ln x, it's ln 1 plus x. Makes sense. 1 plus x. And to get it to be 3/2, you sub in a half to get 3/2. Okay, well, there you go. So this is used for that. Any questions there?
No.
So we could do exponential differentiation or just exponentials in general.
In general.
Okay, so this is y is equal to 2 to the x.
Oh, I just need to do like differentiation. I don't need to do the whole thing.
Say it again, sorry.
I think I just need to do like differentiation. I know what. I don't need to revise the logs.
Okay. Let's just remember where it is. So it's 9. Yep. So we did this bit already. A to the x ln a. We did it with like 2 to the x.
Yeah.
Okay. How about these?
So the first one would be dy by dx is equal to 3e to 3x plus 3 times 2 to the 3x.
Yeah, and because of Bidmas, you can't.
Wait, you have to times ln 2 as well, I think, for the second part, the 2 to the 3x.
You're right. Ln 2. Yep.
Yeah, that's it.
Okay, B.
Three over x, I think. Oh, wait, no, yeah.
What you could say. Let me think about this. Could you not just say 1 over x cubed?
I don't know. I think so. Um, 7x. That's 1 over 7x.
You would think so. How else can you write that? Ln 7x.
I don't know.
Ln 7 plus ln x.
Oh, okay. So 1 over 7 plus 1 over x. Wait, no, ln 7 is just a number, so it would be 0.
Yeah.
So then it would just be plus 1 over x.
Yeah.
Makes sense.
Let me check B. That ended up being 4. That was 3 ln x.
4 ln x.
Hang on, so that is 3 ln x. Okay, and so derivative of 3 ln x. Any idea what derivative of 3 ln x is?
No.
That will be 3 times 1 over x.
Okay. That's what I said at first.
So what do you get there?
4 over x.
And I think that's what they got. Yeah. Okay, C.
Do product rule for part C.
Quotient rule?
Yeah, I meant that.
Yeah.
So you do, well, one of them would just be 0. And then the other one would be the differential 3e to the 7x.
Hang
So
on.
e to
Hang
the
on. I have a better idea. 2 over 4e to the 3x minus 3e to the 7x. Yeah.